Welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buetow, president of the PCEA. My guest today is Madan Jagernauth, marketing director and project facilitator of the High Density Packaging User Group Consortium, also known as HDP. HDP is a nonprofit trade organization that brings together companies in the electronics industry to work on an array of technical problems in order to reduce the cost and time to market. Thank you for joining me on PCB Chat today, Madan.
Good morning, Mike. Thanks for having me. Looking forward to chatting.
I'd like to take a moment to remember Jack Fisher, who was a driving force for collaboration across his nearly 60 years in the electronics interconnection industry. I know how much he meant to HDP, where he worked for nearly 17 years, but he was also very special to me as a mentor, advisor, and confidant. Jack wasn't a self-promoter, and I always kept our side conversations out of public view, but he was a tremendous personal supporter for me over the years, and I'll always be grateful to him. So my condolences to his family and also to the whole HDP community for the loss.
Well, thanks, Mike. Jack was our friend. We lost him this year. He's an icon of the industry. He had a distinguished career before he joined HDP at IBM. He did great work for us in HDP over the years he was here. We miss him. He's an IPC Hall of Famer, right? So I think everybody knows Jack.
Yeah,
he will not be forgotten.
It sounds like HDP actually is going to take some steps to ensure that by they've named an award after him.
That's correct. Jack Fisher Award of Distinction. So, it will be awarded not annually, but on a basis of achievement. Mm-hmm. So as folks apply the types of distinction or show the types of distinction that Jack had, awards are made on that basis.
Well, it's a fitting memorial, and it's the right organization to do it. So I'm grateful to HDP for continuing his legacy. There's no elegant way to segue, but let's go ahead and dig into your latest research. HDP completed 7 projects in the past year, which seems like a lot, but it's actually right in line with your typical output. When we spoke last, you had 24 ongoing projects, so quite a few wrapped up at the same time. One of those projects was the low silver alloy solder paste reliability BGA project, which was led by Nokia. I know that group evaluated reliability in multiple ways, and as part of that project, they also looked at laminate materials. So let's start there. Any surprises from that work?
No, not really surprises. The low silver alloy project was looking at what's called mixed metallurgy alloys. So it was a third generation solder paste with SAC 305 solder balls. And basically it was looking to see whether the resulting alloy was, how reliable the joints with the resulting alloy really are. And uses the typical test vehicle we've used for many a year. It was initially designed by Alcatel-Lucent way back when. This is something that Richard Coyle has been pushing along year over year. The results showed that the mixed metallurgy solder joints are more reliable than SAC 305 solder joints, where you use SAC 305 paste and solder balls. That's the short of it. Richard and the collaborators prepared and presented a paper at SMTAI last November on some of the results of that study. At the time, there are 2 devices used in the test vehicle, a 192-pin BGA and an 84-pin BGA. At the time they did that paper back last year, the 192-pin BGA device had reached N63, but the 84-pin device had not yet reached N63. So they had to wait until all of that was done before they could do their final report. As usual, the final reports are held within HDP for use by our members, and some subset of the results may be published in the industry at one of the conferences that are chosen by the members of the project.
When you say that the alloys tested were more reliable than SAC. Was that across a variety of environments, or were you just using a few different ones?
I think in that particular project, it was a single thermal cycling profile. And I think it was a standard profile for telecom products that was being tested, and with a 10-minute dwell time at both ends. We have two other projects underway at present that are testing three thermal cycling profiles, but those are not mixed metallurgy projects. Those are pure third generation alloys, and uh, that's a large project. It's been underway since 2020 or before. It takes a long time for that to reach completion. I'll tell you a little bit about it. We are partnered with INEMI on this project because it's so large. So we provided some of the materials and stuff like that and the test vehicles. One of the INEMI members did the assembly of the project, and then Nokia, Collins, CAS, and the Universal Area Consortium are all working on testing of the thermal cycling and thermal shock. So it's two phases to that. One of them is looking at thermal cycling with a 60-minute hold at the upper temperature and lower temperature, and those are being run by Nokia, Collins, and CALS. And then Universal is working with us on this to do a thermal cycling to thermal shock comparison. Because what happens with thermal cycling, with these very reliable alloys we have nowadays, it takes a very long time to get to N63. So one of the objectives is to see if thermal shock can replace thermal cycling as a means of getting the testing of the evaluation of solder joints done faster.
And just explain to me, how it works in terms of your material selection. So the alloys that you're using to look at, and the parts that you're using on the boards and the boards themselves, are these all being supplied by HDP members, or in some cases, do you have to go outside because maybe you don't have a member company that has or supplies the type of substrate or some kind of baseline material that you want to use?
So the test vehicles are designed by HDP members. The test vehicles are manufactured by HDP members. We have 4 or 5 PCB fabricators as members. So this is pretty standard types of fabrication of these things. The devices are daisy chain devices, and we've used the same Amcor daisy chain devices for many a year. Amcor is not a member, so we have to buy those. And then, depending on who has the test capability, members will provide the testing capability for us. Right? So.
Got it. Now, a brief word from today's sponsor. This podcast is brought to you by PCB West, the largest conference and exhibition for the electronics industry in the Silicon Valley. PCB West 2023 takes place at the Santa Clara Convention Center, September 19 to 22nd, with a one-day exhibition featuring more than 100 companies on September 20th. Visit PCB West for details. Madan, another just completed work was the copper surface roughness model. I think most folks would agree that the surface roughness models needed some updating. I mean, some of them date back quite a ways. And while there are new tools, they needed to be validated. I know HDP was developing a test vehicle for that. Can you describe that test vehicle and share whether you accomplished what you were looking for?
Well, actually, I can't say too much about the test vehicle, Mike. What I can say is that copper foil surface roughness is a great interest to a lot of our members because of the impact it has on high frequency circuits. So there are a number of things that affect the high frequency, the performance of high frequency circuits. Surface roughness is one of them. The final treatment on the top of the circuit is also has an impact on the performance of the circuit. This is not completed work. This is ongoing work because there's a project we have right now that's looking at a new method of measuring surface roughness. That's a non-contact method as well. So that's work that's underway, and we'll see how that comes out. That one we're trying to get meet the IPC gauge R&R requirements on, so we can actually submit it as a test method to the IPC. So that's ongoing work. We also have a high frequency surface finish project that's looking at the effect of surface finishes on insertion loss, and that project will be testing up to 112 gigahertz. So this is one small part of a bigger area of study that looks at how do we get to smoother copper foils that meet the peel strength requirements for reliability in printed circuit boards and meets the objectives of PCB designers for the challenges they're facing for high speed, high frequency. The reason we're going to 112 gigahertz is because of the next generation optical networks, the 1.6 terabyte networks that will be operating at 112 gigabaud, right, to get to the speeds that they're looking for in optical networking. And the wireless guys are talking about sub-terahertz spectrum from 90 to 300 gigahertz or something like that. And when you start to get to those speeds and that cycle rates on the printed circuit board, the distance you can run a circuit on the PCB with copper becomes very short, even with the very low decay substrates we have, right? So it's a very very complex area of it. So the one type of project is just one part of a bigger whole that we're looking at.
Yeah, those speeds are staggering. I mean, at PCB West, kind of the high end is 56 gigabits per second. So when you're talking about what the speed's capable on fiber and light, it's just is really something. But for those of us who are, spend most of our day in front of a computer or on a phone, personally, I'd appreciate anything faster is better to me.
Remember when the Commodore 64 came out and 64 meant kilobytes?
Yes, yeah, it's a great point. I mean, I was stuck on how back in the late '90s, early 2000s, we were wondering whether we could get more than 5 gigabits per second through copper, and we blew past that order of magnitude. But but along those same lines, HDP has been looking at laminate materials almost since the beginning of the organization, and it's hard to think of too many mainstream materials that you haven't tested. What is the latest for the lead-free bareboard materials project?
We're in phase 7 of that project. That project, the first report came out in 2007. So it's been 15, 16 years, right? The genesis of that was lead-free solders, where the materials at that time could not stand up to the higher temperatures of lead-free solders. This has been a project which takes years to get done. From the time you select the laminate to the time you run through the full set of tests. What they're looking at now is it's still called lead-free material 7 because it has to work with lead-free solders, but it also has to do more stuff like high frequency. And what we're seeing is as laminate technology is going towards mixed resin formulations to get to low CTE and to low decay, we're seeing multiple T sub G points. And some of the study is about how do you focus on the actual performance of the material versus just using T sub G as a go, no go kind of thing. So the selection of the materials has to do with the set of parameters that the team sets at the beginning to say it has to meet these types of criteria. And then material suppliers, and we have a large number of material suppliers as members, will offer specific formulations of theirs that are available at the time to use in a project to see what the reliability of materials are. This is one of the most popular projects inside of HDP. Large participation across the board from material suppliers to fabricators to OEMs. The test houses are very interested in it as well. So for this, there's a standard test board that's been used for a while, MRT6. There's a revision for MRT7. I think they added some circuits to it. I don't know what all they do on it because I don't pay too close attention to it. But that's a project that started probably last year, I believe, and it's targeted to run through 2025. I mean, it takes a good long time to do all of the testing on something like that.
I'd like to point out, of course, that HDP really covers the gamut of the electronics interconnection industry, right? So we've talked about assembly, we've talked about fabrication, and the impact on design as well. Another area that impacts multiple disciplines, I think, would be what you call the PCB feature miniaturization project, which is really about stacked microvia designs.
One of the things about this is how do you get more stuff into the same space and make it reliable? As we were talking just now, computers nowadays are so much more capable, and networks so much more capable than they were 20, 30 years ago. The circuits are narrower, and the number of interconnects you have to connect all of the devices are greater. So stacked vias has been a challenge for a lot of folks. Some folks say they have it all sorted, and it's general stuff for them to do. Others are finding that that may not necessarily be the case, and there may be some variabilities that you have to look at. So it's a case of looking at what types of structures you can have so that you consume as little real estate as possible on the printed circuit board, while managing whatever materials you're using to get that structure to be reliable, right? So low CTE materials, how much expansion you can get in the Z-axis, how reliable is it? So it's a case of trying to get more into the same space.
And any HDP member can gain access to the results.
Yeah, we have a very simple business model. If you're a member, you have access to all current projects. You can participate at will. You have access to all of our library. And I downloaded that library. It took me days, if not weeks, to download them all.
I guess that's why we need these high-speed machines.
And when I say membership is by company, not by individual. So when a company joins, all of their employees can participate in a project. So it's a question of how much time they want to allocate to participate in projects. I want to go back a little bit to that. You talked about the material stuff and how much we've done. I want to talk about lead-free solders. I downloaded all these reports, right? Because this is our 30th anniversary year. And I'm looking at it as the marketing guy and saying, I know we've done good work. How can I actually present this to the industry as good work HDP has done over 3 decades, right? So in the first decade, it got formed and it was a small group of about 15 members annually. Now it's at 50 members annually is where we've stabilized. So the second decade was growth years. That's when HDP grew up. And one of the genesis of that was lead-free solders. Prior to 2000, there was some work being done in individual companies. But there was a need to get the ecosystem together with everybody operating on the same page. So early in the 2000s, about 22 years ago, HDP started looking at that and wrote a couple of guidelines on the use of lead-free solders. One of the studies was for something called an alternative solder alloy, which turned out to be SAC 305. Right? It wasn't called SAC 305 in 2002, but that's what it is now. And that was the genesis of a long series of work on lead-free solders that HDP has done. There are 12 projects that have been completed in 20 years, and there are 3 underway, including one on photonic soldering. Same thing on the material side. Over the last 15 years or so, there have been 12 projects completed, and there are four more underway right now on materials. So there's a long thread that runs through it. So if a member looks back, and some of the members have been there from the beginning, um, if you look at that, you'll see the evolution of technology over time and the evolutionary work that HDP has done and the members of HDP have done to to help drive the industry forward. Some of the projects we run do more than just address what members need. Some of them are designed to uh, release information to organizations like IPC to help define what new standards might be. So I think right now we have three projects that are designed to provide gauge R&R data that the team can, at the end, if there is a good set of data that can be used by the industry, submit it to IPC for consideration in various subcommittees.
If I think about all of the possible combinations of alloy, flux, laminate, the ball or lead type, the feature size, the work on this will never end. I mean, it's astounding.
Well, that's just it, right? The test vehicle we use to evaluate solder alloys, uses two devices, a 192 pin device and 84 pin device. That's a 1 millimeter pitch and a zero point 0.8 millimeter pitch. And everything else is held constant on this. Only the solder alloys vary. So things like surface treatment is not very just solder alloy because this is complicated stuff. So there's a need, and there was a project idea that was proposed to test the solderability of different surface finishes. We haven't launched that project yet because I'm still trying to get more information on what the proposer of the project um, had in mind. But then when I look also at the timeline of how long it takes to run a solder reliability test, I want to make sure that all of the next set of stuff we do on evaluation of solders comes together in one place so that when we get into the ovens, we have everything in the oven at one time, rather than trying to have three projects on three timelines, three sets of test vehicles running forever. So there are some of these efficiencies we have to really look at when we get ideas, look at what's logical to do together.
So you've managed to complete 7 projects, but you still have 20 plus that you're working on. Let's hear a little bit more about what else HDP has underway right now.
So, we report our progress in an annual report that's published usually this time of year. It covers July to June of the year. So the 2023 report is just out. Um, so all the annual report is available for download on our website on the annual reports page, and all of the ones for the last 10 years are there. There are a couple of ones I want to mention in addition to the materials project you brought up earlier. The final finish for high frequency. I mentioned uh, copper surface treatment earlier. This is one that is the one that we'll be measuring up to 112 gigahertz. And there's a full set of surface finishes. And I've been learning a new language as I listen in on that project because it's of interest to me. Anipeg and stuff like that, right? Immersion tin, immersion silver, whatever else. So this is going to be one of those projects that sets the baseline for saying, how do these materials affect insertion loss in a circuit? The second part of it's going to be, okay, fine, now we know what the electrical performance is. How reliable is any of these things in the printed circuit board? And it's a final finish, a surface treatment on the final board. That's one of the projects that's high interest to me and to the industry. The second one I want to mention, or the last one I want to mention, is permittivity of cooling liquids. One of the things we're looking at is how does the permittivity of a cooling liquid for direct immersion cooling affect the performance of circuits, and how does the cooling liquid itself hold up over time? There's an initiative from the EU to look at limiting the use of PFAS materials. These are per and polyfluorinated substances. So a lot of the fluorinated substances might get restricted in use. So you have to make sure that as you're looking at things like direct cooling, can you use materials that are not fluorinated and get results that are acceptable to the industry? And, will be reliable over time and those kinds of things. So that's a fairly new project. It got launched about a year ago, and it's coming together nicely, I think. So all of our projects, each project has a web page on our website that has basic information on the project. Typically, the way it works is if you're a non-member, you can see some basic information, and members, the entire set of materials for that project's on that page. The page stays up forever, so even completed projects, there's a page there with final report and all the test data and minutes of meetings and all of that stuff. So we have a really good website.
And what's the URL for that website?
hdpug.org.
hdpug.org. Okay.
Yeah.
In your annual report, HDP Executive Director Larry Marconti says this quote from Alan Kay, which I love: "The best way to predict the future is to invent it." Now, Kay, by the way, was one of the Xerox scientists who helped invent Ethernet and the graphical user interface. So, I mean, he wasn't just blowing smoke. How does HDP feel when it comes to its mission? Is the mission to help its members improve and implement technology, or truly create something from scratch, or perhaps some of both?
So the key thing about the printed circuit board industry is you have to have an ecosystem that can work very well, right? We've gone away. When I came into the industry all those years ago, all the companies were vertically integrated and competing with each other tooth and nail on the fabrication of boards. So, for example, I was at Honeywell, and I never was invited into an IBM manufacturing facility. HB invited me into theirs because we weren't competitors, but that's the way it was. But the genesis of HDP was to get companies in the ecosystem participating together to work on projects that no one company can do very well, or would spend a lot of money replicating if they were all doing it in their labs. And the cost of a project is conservatively about 100K. Conservatively, if any one company tried to undertake the set of projects that HDP does all by itself, they would not ever get anything done. So the key thing here is how companies, what we enable really is to let the companies in the ecosystem who are bringing new and innovative things to the market on the supplier side, right? The material suppliers, the equipment suppliers, whatever they are, right? Whether it's laminate materials or chemistries or whatever. And the demand side, the OEMs who are pulling for higher speed circuits and denser circuits, to work together to say, here's a set of things that we understand in a non-proprietary or non-competitive way, right? So that they can then take those back into their companies to create the differentiated products that will let them succeed in the marketplace. So we just create a level playing field for everybody, and whoever wants to play gets to play, and who doesn't want to play, well, it's.
You have a meeting coming up next month. What can you tell us about that?
Well, we are back to normal operations. In the last year, we've had 3 face-to-face meetings, including the first in Asia since 2019. So we're happy to be back to normal operations. And that one was hosted by Mitsui Kinsoku and Omiya. It's good. The next one is a virtual meeting that's running on the 18th and 19th of October. And the usual format of this is in the first day, we have a guest speaker and we look at projects that are in the early stages. And the second day, we have projects that are in the implementation phase that will have data. So the first day, we invite non-members and potential members to attend as well. This time, we have as a guest speaker Matt Kelly, who is the Chief Technologist at IPC. Matt will be speaking on the subject of silicon to systems, basically an approach to bolster regional and global ecosystem, what's happening with the chiplet trends and the impacts and the needs. And, chiplets are not something we've done a lot with, but it's something that we have to start looking at, I believe, as we get to these higher frequencies and shorter circuits on the organic substrates. So it should be a very interesting talk by Matt.
Matt's an excellent technologist and a wonderful speaker, so I suspect it will be a very good presentation. I'll remind listeners that this podcast is brought to you by PCB West, which takes place at the Santa Clara Convention Center September 19th to 22nd, with the one-day exhibition featuring more than 100 companies on September 20th. Visit pcbwest.com for details. Madan, before we close, did you have anything else you wanted to mention?
If anybody wants to reach out to me, I'm available by email, so they can email me, madanj@hdpug.org, and be happy to talk with them about any of the subjects of what we're doing to the extent that I can. And we always welcome new members. So, we're doing interesting work. We invite everyone in the ecosystem to consider joining HDP. We invite everyone in the ecosystem to submit ideas if they can't join or for whatever reason. If they think there's something that would be of interest to the industry that HDP members should be considering, then we entertain ideas from any source. So, it's, that's it, I guess, Mike. I appreciate you taking the time to talk with me today. Hope PCB West goes well next week.
Thank you. Well, thanks again for catching us up on the latest with HDP. And I'll remind folks the URL is hdpug.org. For PCB Chat, this is Mike Buetow. Have a good day.